It's a CBSE question in collisions work power energy. Problem is like this. A metal ball of mass 2 kg moving with a velocity had an head-on collision with a stationary ball of mass 3 kg. After the collision, if they move together, what is the loss of kinetic energy? First, let's take down the data given for you. M1 is 2 kg, U1 is 36 km per hour. I have to convert that kilometer per hour into meter per second because that's SI system. We know 1 kilometer equal to 1000 meters, 1 hour equal to 60 minutes, and each minute equal to 60 seconds. So if we cancel these two zeros, it becomes 36 into 10 by 36. That's nothing but 5 by 18. So a conversion factor from kilometer per hour to meter per second is 5 by 18. So 18 twos, that is 10 meter per second. That's the given data. Collided with another body of mass M2 equal to 3 kg, who is in the state of rest. And after the collision, they move together. It's a perfect elastic collision. That means V1 equal to V2 equal to V. Let's apply law of conservation of momentum. Let's apply law of conservation of momentum, which says that when no external force is acting, initial momentum of the system is final momentum. Initial momentum means m1 u1 plus m2 u2. Final momentum equal to m1 v1 plus m2 v2. m1 is 2, u1 is 10, m2 is 3, but u2 equal to 0. They are moving together, m1 plus m2 having a common velocity v. So 20 equal to m1 plus m2 means 2 plus 3 times of common velocity. So common velocity is 20 by 5, 4 meter per second. But what he wants is loss of kinetic energy. For that, let us calculate kinetic energy initial of the system. Half m1 u1 square plus half m2 u2 square. But u2 is, that term becomes automatically 0. Half m1 is 2, u1 is 10 square. That is 100 joules. Let's also calculate kinetic energy final. Half, as they are moving together with a common velocity, half m1 plus m2, that is 2 plus 3 of v square is 4 square. That is half 5 and 16 to 8s. That is 40 joules. So loss of kinetic energy is Ke initial minus Ke final. That is 100 minus 40, 60 joules. So in this inelastic collision, 60 joules of energy is lost. So in solving this problem, we have used a very simple thing that when no external force is acting, momentum is conserved. Taking that into consideration, I have calculated final velocity and I have calculated energies and I have also calculated the loss of energy. That's how we solve the problem. Thank you for watching.